Good morning, all. So we'll be doing the deck, the bulkhead where it is touching the deck. That is the bulkhead deck. So in every passenger ship, the lowest most continuous deck after the collision bulkhead is termed as bulkhead deck. The volume under the deck is subdivided by steel transverse bulkhead, which are watertight. So that makes the machinery space watertight, comprising of a separate main motor room, boiler room, generator room. Other spaces will be storeroom, baggage room, cargo holds, and passenger cargo ships. And this deck is called bulkhead deck since the watertight bulkheads are extending up to this deck. Sometimes you get this what is bulkhead deck, the definition you have to write. Then what is floodable length? And what is the distance difference between floodable length and permissible length? So the floodable length of a watertight compartment is defined as a maximum length of compartment with reference to the midpoint of the considered length when flooded by bilging will cause the ship to sink to a level coinciding with an imaginary line which is known as margin line. So basically margin line is an imaginary line 76 below the bulkhead deck. So the line parallel there is a margin line. So floodable length of a watertight compartment is defined as the maximum length of a compartment with reference to midpoint of a considered length when flooded by bilging, which will cause the ship to sink to a level coinciding with imaginary line, which is marginal. Now, this length is determined by applying your principles of stability and flotation, considering symmetrical bilging. So, symmetrical bilging means both sides the bilging is same, and assume permeability as given in that regulation. So, we'll go to more details of that in the other topic in the other notes. But first, we'll do the basics here. What is permissible length? What is the formula of permissible length? Now, maximum permissible length of a compartment having its center at any point of the ship's length is obtained above when multiplied by a constant less than 1. So, permissible length is you're multiplying the maximum permissible length of a center at the midship of ship's length as obtained above. When multiplied by a constant less than 1, the permissible length is obtained. And this factor provision is made so that the ship will remain afloat with the margin line above the water line when the compartment is flooded. Just another definition so it will be absolutely clear. We'll do the other lengths also. So permissible length is floodable length into factor of subdivision. That formula is there. Permissible length is floodable length is a maximum length by the calculation which is considering block coefficient, draft, and characteristics. When you multiply floodable length into factor of subdivision, you get permissible length. Now we'll do what is the other factors, then we'll come back to this definition. So PL is equal to FL into factor of subdivision. Now the factor of subdivision shall depend on the length of the ship. So that's a factor which is less than 1. So that means how many subdivisions you're making. So factor of subdivision will depend on the length of ship, and for any given length shall vary according to the nature of service for which it is intended. It shall decrease in a regular continuous manner. As the length of the ship increases, the factor of subdivision will decrease. Now, the formulas will come to for this factor of subdivision. So, from a factor A applicable, which is primarily for vessels engaged in carriage of cargo, and factor B is when it is engaged in carriage only of passengers. These two factors are there. So L basically is length between perpendiculars. So A is equal to factor A is for cargo ship and factor B is for passenger ship. Right. The formula will go haywire. I'll just remove this. Factor A is for passenger ships. Factor A is for cargo ships. I'll just write here. I'll remove this. Then again, that formula is going wrong here. Move this here. So A is basically, I'll just write here, this A is factor A applicable for carriage of cargo. Factor B is applicable for passengers. So A is equal to 58.2 divided by L minus 60, where L is greater than equal to 131 plus 0.18. And factor B is for passenger ships for L greater than equal to 79 meters. It's 30.3 divided by L minus 42 plus 0.18. So when you multiply, when you combine A and B along with criterion service, now we have CS number, then you get appropriate factor of subdivision. We'll do what is CS. That is, there's a formula for CS. And this CS, there's two formulas there. We'll do that. And then we'll do the rules for subdivision with F. That is, you're taking F into account. So we'll do that also, and along with example. So you've done A factor, which is for cargo ship. B is for passenger ship. You combine that along with CS, you get factor of subdivision with a formula there. So CS is for a ship of given length, the appropriate factor of subdivision shall be determined by CS, where CS is the criterion numeral, L is the length of the ship in meters, M is the volume machinery space. So that is in addition to the volume of permanent oil fuel bunkers, which is situated above the inner bottom and forward of or abaft of machinery space. That includes volume of machinery space. P is the volume of passenger ships below the margin line, and V is the volume of ship up below the margin line. So P is the volume of passenger spaces below margin line, where V is the whole volume of ship below margin line. So P is equal to K, which is a constant, that is 0.056 L, and N is the number of passengers for which it is certified. So P1 is equal to K into N. Now we see where the Kn, when the value of Kn is greater than the sum of P and whole volume of actual passenger spaces above margin line, then the figure is taken as P1. That is the sum or 2/3 of Kn, whichever is greater. So Kn we have done is P1, and P1 is basically when the value of Kn is greater than sum of P and the whole volume of actual passenger spaces above line. Then P1 is taken as sum or 2/3 of Kn. Otherwise, P1 is equal to Kn. So the second criteria of P1 is when the value of Kn is greater than sum of P and the whole volume actual passenger spaces above margin line. Then P1 is equal to sum of the sum or 2/3 of Kn, whichever is greater. Now, when P1 is greater than P, where P we have taken is a volume of passenger spaces below margin line, then criterion of service numeral is 72 into M is the volume machinery space, including your permanent fuel oil bunkers above your inner bottom and forward or abaft of machinery space, plus 2P, where P is the volume of machinery spaces below margin, volume of passenger spaces below margin line, divided by V, which is the volume of the ship below margin line, plus P1 minus P. When P1 is equal to P or P1 is less than P, then CS is equal to 72 into M plus 2P by V. That is a value of criterion of service numeral. Now, for ships not having continuous bulkhead deck, now suppose there's a break in bulkhead deck, then the volumes are taken up to the actual margin line used for determining the floodable. So then we take it, volume is taken up to the margin line. Otherwise, it's taken up to the bulkhead deck. Now, the rules for subdivision of special trade passenger ships, which is passenger cum cargo ship. So subdivision above the forepeak of 131 meter in length and upwards has a criterion numeral of 23 or less shall be governed by a factor A given by the formula 1, which we have already done. Factor A is your this of having a criterion number of 123 or more, 23 or less likha hai. 123 or more given by a factor of B, of which the criterion number is between 23 and 123 by factor F obtained by linear interpolation between factor A and B. So then we get F criteria of factor F, which is A minus B into CS minus 23 divided by 100. So nevertheless, when the criterion numeral is equal to 45 or more and simultaneously the computed factor of subdivision as given by the formula is 0.65 or less, but more than 0.5, the subdivision above the forepeak shall be governed by factor 0.5. So that is when your criterion number is 20, CS is 45 or more, plus your subdivision is 0.65 or less but more than 0.5. Then the subdivision above the forepeak shall be governed by factor 0.5. The second criteria is when the factor F, this factor, is less than 0.4 and is shown to the satisfaction of flag state to be impracticable to comply with the factor F in machinery compartment. The subdivision of such compartment may be governed by increase factor, which shall not exceed 0.4. So these are the criteria here. Now, that was for special trade passenger ship versus passengement may be governed by increase factor, which shall not exceed 0.4. So these are the criteria here. Now, that was for special trade passenger ship versus passenger cum cargo ship. That was the rule for that subdivision. Now we have subdivision for only carriage of passengers. So in case the ships are engaged in the carriage of passengers, the subdivision above the forepeak shall be governed by factor 0.5 or by a factor determined according to paragraph 3 or 4 of this regulation if less than 0.5. Now subdivision above the forepeak of vessel 131 meter in length and upwards, having a CS of 23 or less, shall be governed by a factor A given by formula 1, which we have done. A, the formula of A, which we have already done, is here. This formula. So subdivision above of this and upwards of criterion supernumerary 23 or shall be governed by factor A, and above of these having criteria of 123 or more by factor B, or BP, but factor B. Given by the formula above are having a CS between 23 and 123 by the factor. This is BB. Okay. It should be not BB, but B. It should not be BB. So the factor B will be given by the formula above and also having a criterion number CS between 23 and 123 by factor F obtained by linear interpolation between factor A and B, which is F is equal to A minus A into A minus B into CS, not C5, but this is CS, minus 23 divided by 100. So except that the factor F so obtained is less than 0.5, the factor is to be used either 0.5 or the factor calculated according to the rule of passenger cum cargo ship, whichever is smaller. So factor F, if it is less than 0.5, then it will be as per this formula, passenger cum cargo ship, this formula. Now suppose there's an ro-ro ferry ship. So if your length of vessel is, how do you determine factor of subdivision? Suppose it's given that the formula is given here. Length is 139, breadth is 32, depth for freeboard is 8, volume of machinery space including bunker deep tanks is 4979, volume passenger space is 3148, total volume underwater volume is 2248, number of passengers and cab drivers 200. Bulkhead deck is 4 meters below the freeboard deck. Heavy trailers and trucks are stored on bulkhead deck and the lighter cars are stored on the freeboard deck. There is one ramp connecting the freeboard deck and bulkhead deck for movement of vehicles. And the passenger accommodated in the upper deck, which houses the crew and officers of the ship. The upper deck is not a superstructure but a accommodation. So you have a formula. V is equal to 30.3 divided by this is 0.492. So CS becomes, you take this P1, K into N. K value is 0.056 into N. N basically is number of passengers, so that is 200. Length is 139. So you have P1 is equal to this factor. Now P is 0, so P1 is applicable. So P is given as 0, so you will have applicability only of P1. You have M is 4979. So CS is A into this A is given 72. CS का फॉर्मूला था 72 when P1 is greater than P. So we have 72 to M plus 2P divided by P plus P1 minus P. So here you have 72, and because P is 0, so then you multiply that and you get a factor here. Now you apply to F. You have A, which is 0.492, and A minus B, you have this figures. Then CS, you get this figure, minus 23, you get this divided by 100. So you get a figure is you get a figure as you subtract that, you get a figure here. That will be considered as, so that will be 0.486. That will be considered as 0.5. There you get the F factor here. Now, how you assigned the freeboard here, we'll do that also with the examples. Now, in order that the degree of subdivision shall be maintained, a load line corresponding to approved subdivision draft shall be assigned and marked on both sides. The ship having a space which is specially adapted for accommodation of passengers and carriage of cargo alternatively. If the owners desire, have one or more additional load lines assigned and marked to correspond with the subdivision draft, which the administration may approve. Now, let me show you the subdivision draft and then we'll come to this. So here, no, they have not shown this. Yeah, C1, C2 is there, which is below your sum of freeboard. These are your subdivision drafts for passenger ships. C1 is fair weather, and C2 you have more freeboard and foul. So C1, C2 are basically for passenger ships, special trade passenger ships, freeboard. If you notice, C2 is more than C1, then C3 is more than, freeboard is more than C1. So that is a passenger ship freeboard, which is to be assigned on both sides. So subdivision load line assigned and marked shall be recorded in passenger ship safety certificate and shall be distinguishable by notation C1 for principal passenger condition. That's fair weather condition. C2 and C3 for alternative conditions can be foul or very foul conditions. Freeboard computation on each side of the load line shall be measured at the same position and from the deck line as per the freeboard of International Load Line Convention. The freeboard corresponding to each approved subdivision load line and conditions of service which is approved shall be clearly indicated in passenger ship safety certificate. In no case shall any subdivision load line be mark be placed above the deepest saltwater line as determined by the strength of the ship. Whatever may be the position of subdivision load line marks, a ship will no case will be loaded as to submerge the load line mark, appropriate for the season and locality as determined in accordance with International Load Line Convention. A ship in no case shall be loaded that when in salt water, the subdivision load line mark appropriate to the particular voyage is submerged. Now for the competition of freeboard, required freeboard for the fully laden condition is worked out on assumption that in bilge condition of the largest compartment, which is usually the machinery space, the margin line should not be submerged, and this freeboard draft and the deepest subdivision draft, other drafts will be worked on and assigned to the loading condition. So on the basis of the method suggested, the subdivision freeboard is worked out and it should be understood with the working approximate, since considerable data is neither available nor assumed, which is otherwise required for the proper design. So here we'll have the explanation. Now suppose a Ro-Ro ferry ship is there, and the distance of bulkhead deck from the freeboard deck is 4 meters. Location of margin line is 4.076 meters from the freeboard deck. Freeboard draft at C1, the full load is 3.7. Since the factor of subdivision worked out to be 0.5, the machinery space is divided into two watertight compartments connecting the approved type of watertight door. Length of each machinery compartment is assumed to be 20 meters and breadth is 32 meters. Now we're taking assumed permeability machinery space is 0.85, and the machinery space is assumed to be the largest and the bulkhead deck, and this is assumed to be damaged and bilged to sea. Now, assuming the area of coefficient is 0.75 in the water plane area, the actual water plane area will be this much, 10449 meters square. So volume of lost buoyancy of the machinery space, you have this calculation. Then you have intact water plane area, we have done all that in stability. Increase in draft is 0.2052 meters. The new draft will be this. So the position of margin line is 3.924 meters from the keel, and hence the margin line is not submerged. Now this draft of 2.7 meters can be assumed to be the freeboard draft for fully loaded condition, and this load draft will be indicated by C1, the topmost. Now this is conditional to load in fair weather loaded trailers on bulkhead deck, cars on freeboard deck, and 200 passengers in passenger space accommodation above. Now in foul weather, the ship does not have any rolling stock but carries 200 passenger accommodation with cars stored on bulkhead deck. In this condition, the ship will be floating at a lower draft, which is 300 mm below C1 and indicated by C2. We have another example. Now consider a special trade passenger vessel, which is cargo cum passenger ship. Your length is given, the breadth is given, the depth is given, the coefficient is given, the area of coefficient of water plane area is 0.75. Bunk passengers carrying accommodation provided in spaces at bulkhead deck, freeboard deck, numbering 540. Volume bunk passenger accommodation of 1890, considering 3.5 meter cube per passenger of space. Volume machinery space is 60,000 meter cube. Underwater volume is 136,000 meter cube. You find factor A, CS, and you find T1 here. Then volume of actual passenger space is less than 7840. So we have 2/3 of that, which is greater than P. So P1 is given a value of 2/3 of this value. So CS you find out will be 36.45. Then you find out what is factor F. Basis formula. So you get 0.5147. Now, as per regulation, the factor of subdivision cannot be greater than 0.5 for this class of ship. So since the factor of subdivision is 0.5, it follows that the machinery space is divided into equal spaces by watertight bulkhead fitted with the watertight door, and the space is equally divided. To find a maximum permissible draft in a fully loaded condition as per this regulation, assume the height of bulkhead deck 9.75. So you got various other formulas. We'll not do all that formulas. So I think that is now you understood what is C1, C2 by this criterion, or CS, and what is C1, C2 by the examples. So we have done the examples. You will not have those calculations to be done here, because this is tonnage, so you don't have to do calculations. Calculations will only be for stability. This is only for you to understand what is C1, C2. That's why I've done this. And then you understand the formula, otherwise it'll just be mugging up. That's why we have done some examples here, so that you understand what the formula is. Now, progressive flooding is basically when your vessel is sinking so that the water enters the undamaged compartments. That is progressive flooding. CS we have done. Now, what is the information available with the master? We have already done there. I think we can do that again. What is the stability information? We'll do this now. Damage conditions we have done, we'll do it again. There is a curve known as a curve of floodable lengths. This normally is not asked in your exams. It can be asked what is the orals, what is this curve of floodable lengths. Now, how do you find number of bulkheads? That is where it should be placed. The permissible length of each compartment has to be determined. Permissible length is floodable length into factor subdivision. So you have number of bulkheads from that. Now, the function of floodable length, which is obtained from a graph. How do you obtain floodable length? Basically, is from the graph, which is known as curve of floodable lengths. So every point in this curve has an ordinate representing the length of vessel, which may be flooded to the center of the length of that point without submerging the margin line. So even if you have a building maybe forward or aft, you don't have to submerge the margin line. So what is the length available for that, of that compartment? So this curve is used for assessing the vessel's stability in damage condition, the curve of floodable lengths. From that you get your floodable length. So damage due to flooding will be unsymmetrical flooding is that which occurs when the amount of water is more on one side than the other. So that way the ship will heal. Maximum angle of heel after unsymmetrical flooding should not exceed 15 degrees. Where it is necessary to correct the seal, any means adopted to reduce this should be self-acting. The control should be operable from above the bulkhead deck. That means the heel of correction should be done above the bulkhead deck. So if the cross-flooding fittings are installed, the time of equalization should not exceed 8 minutes. So you have anti-healing tanks there in Ro-Ro vessels to correct that heel, which we have done in construction. Now, after assumed critical damage, the final condition should be such that if unsymmetrical flooding takes place in one compartment, the angle of heel should not exceed 7 degrees. It is more than adjacent, 2 or more adjacent compartments should not exceed 12 degrees. If symmetrical flooding takes place, the final GM should not be less than 50 mm as calculated by constant displacement method. Now, what is the information available to master? He should be supplied with suitable information concerning the use of cross-flooding fittings. He should know whether the fittings are there. He should be supplied data necessary to maintain sufficient intact stability under service conditions to enable the vessel to withstand critical damage. And that includes maximum permissible kg or the minimum possible GM for the range of drafts or displacement, which covers the service conditions as well as influences the various trims, taking into account the operational limit. Now, in case where the ship requires cross-flooding, the master should be informed of the condition of stability on these calculations of heel as based on the moments due to crowding of passengers, moments due to launching of fully loaded survival craft on each side of the vessel, moments due to wind pressure, the volume and service permeabilities. Then the master should also be aware that the extent of damage is assumed within that parameter. Plus, he should be warned that excessive healing may result in ship sustaining damage when there is a less favorable condition. So the stability information is that all passenger ships and cargo ships about 24 meters in length must be inclined after the construction. So the inclining test must be done. And the master must be provided with enough information so that he can rapidly and accurately obtain the ship's stability under various conditions. There are alternations to the ship that affects her stability. That should be amended information of the same. If required, the ship should be re-inclined to determine the new condition. So at periodic intervals not exceeding 5 years, a light weight survey should be carried out on all passenger ships to verify if there's any change in the light displacement and longitudinal center of gravity. And if there is a change of over 2% on the light displacement or over 1% on the length or in the LCG, the ship should have been re-inclined and the test results to be there. So this is a subdivision load line we have done, either this side or this side, but it should be below your summer load line. So these are your C1, C2, C3, that is for principal passenger carriers, passenger in twin decks, passenger in lower decks. Then you have a further C3. Now, what is unberthed passenger ships? So you have special trade passenger ships where another kind of subdivision is used for Indian vessels. That is D1, D2, D3. Those are known as special trade passenger ships, which have greater freeboard than sea lines also. So that is only for unberthed passenger ships, where they are lying on the deck. So you have different lines, which is D1, D2, D3. Now that will be below your C1, C2, C3, C3. So during Simla Convention of 1931, due attention was given to special trade passenger ships carrying unberthed deck passengers between Singapore, India, Gulf, Red Sea, those Hajj passengers. So to provide additional safety, you had another series of load line known as D1, D2, D3, which had greater freeboard than sea lines, and they are known as special trade passenger ships in India. That is what I wanted to do, so that you know for unberthed passenger ships which are the special load line. D3, which had a greater freeboard than sea lines, and they are known as special trade passenger ships in India. This is what I wanted to do, so that you know for unberthed passenger ships which are the special load line. अब subdivision index भी कर लेते हैं. Basis that कि subdivision index क्या है, कि ये आया था about 9 साल पहले. One of the students had asked me, उसका note फिर मैंने बनाया. So the subdivision of ship is required, considered sufficient if attained subdivision index determined in accordance with the regulation 7 is not less than the required subdivision index are calculated in accordance with the regulation. So your partial indices AS, AP, AL are not less than R for passenger ships and 0.5 R for cargo ships. So for damage stability requirements of this part apply. The degree of subdivision to be provided shall be determined by the required subdivision index R. So in case of passenger cargo ships greater than 100 meter length, LS, R, which is subdivision index 1 is equal to minus 128 by LS, which is for greater than 100 meter length, plus 152. In case a cargo ship is less than 80 meters, so the length, if you say, is given by L, and not greater than 100 meter, which is so R is equal to 1 minus 1 by 1 plus L into RO, 1 minus RO, where RO is value R as calculated according to the formula in subparagraph 1. Now for passenger ships, we have another R value. The number of passengers less than 400, then R is given as 0.722. It is between 400 and 13450 passengers, and R is given as N divided by 7580 plus 0.623. So this figure plus this. So N plus 0.692. If it is between 1 and 6, R is equal to 0.0369 into ln into N plus 89.048 plus 0.5. The total number of passengers on board, length of the vessel. So it is N is an R is equal to 1 minus 852.5 plus into N divided by N plus 5000. This is index R. What is index? We'll just do that also. So the probability of occurrence of each of the damage scenario ship should be subjected to calculation. We can determine attained index measure of ship's ability to sustain a collision damage. So the probability of ship will remain afloat without sinking these probabilities, your longitudinal center of damage occurs just at the region of ship under consideration. Probability of damage has a longitudinal extent that will only include the spaces between transverse watertight bulkheads. The damage has a vertical extent that will flood only the spaces below the horizontal boundary, that is watertight deck. Next probability, the damage has a transverse penetration not greater than distance by the given longitudinal boundary. And the next condition is probability that the watertight integrity and stability throughout the flooding sequence is sufficient to avoid capsizing. So the first three of these factors are solely dependent on the watertight arrangement of the ship, while the factors 4 and 5 will tip shape. So the last factor is this one. Will also depend on the actual loading conditions. So by grouping these probabilities, calculation of probability of survival or attained index A formulated to include the probability of flooding each single compartment and each possible group of 2 or more adjacent compartments, and the probability that the stability after flooding a compartment or a group of 2 or more adjacent compartments will be sufficient to prevent capsizing or dangerous healing due to loss of stability or to the healing moments in the intermediate or final conditions. So the concept allows a rule requirement to be applied by requiring a minimum value of for a particular ship. This minimum value is referred to as the required subdivision index R in the present regulation and shall be made dependent on the ship side, number of passengers as considered here, color and highlight. So it should be greater than equal to R. As explained above, the attained subdivision index A is determined by a formula for the entire probability of the sum of products of each compartment or a group of compartments of the probability that the space is flooded, multiplied by the probability that the ship will not carry to flooding of the given considered space. So is equal to sigma or P1 into S1, where Pi into Si. So I represents the damage zone, a group of compartments under consideration within the watertight subdivision of the ship. The subdivision is viewed in the longitudinal direction starting from the aftermost zone or compartment. I represents the probability that only the zone I under the consideration will be flooded, disregarding any horizontal subdivision. But taking transverse subdivision into account, longitudinal subdivision within the zone will result in additional flooding scenarios, the zone probability of occurrence. The value Si represents the probability of survival after flooding the zone I under consideration. So if it comes, how you relate index A and R, you write this under the damage stability. This has come once in your paper. एक बार आया है, उसके बाद नहीं आया. So break now. In the next class, what we'll do, we'll be doing all your TNRT modified and alternative time. Plus after that, the excluded spaces and spaces, all that we'll be doing.